Hello students, welcome to the lecture series of Mechanical Measurement course. I am Mohammad Mansoor. In the previous session, we had a look at the course syllabus. In today's session, we are going to start the first unit. The name of the unit is Measuring Instrument. Now, what do you mean by measurement? Can you make an attempt to define it? Yes, measurement means to measure. That is, to assert the size, amount, or degree of anything by an instrument or device, and the result is written in numerical value. Measurement means the determination of anything that exists in certain amount. Determination andre find out ಮಾಡೋದು. As an engineers, we not only measure the physical variables but also control them. In the engineering field, we have different process to control. In order to control the engineering process, we need to control the physical variables. If you want to control the physical variables, we need to measure them. The accuracy of a control is essentially depend on the accuracy of measurement. See, any control process to be accurate, then the measurement which we indulge, okay, the measurement which we take during the process has to be accurate. So basically, the measurement can be defined as the process or the act of obtaining a quantitative comparison. Since I have used the word competitive comparison here, there should be two aspects to be compared. One is the predefined standard, and then second is unknown magnitude. Predefined standard is a standard which are previously defined and set as a standard. For example, a meter scale can be called as a predefined standard in the length measurement. In case of weight measurements, the dead weights can also be called as a predefined measure standards. So let us learn the block diagram of measurement. Measurement means the process of comparison. So here we are comparing two aspects. One is the standard, the another one is unknown magnitude. And these yields the result. And this result is in numerical value with an unit. So this overall process is defined as the measurement process. So let us learn the significance of measurements. The importance of measurement is that it provides the basis for the industrial development, mainly manufacturing, product, testing, food processing. In industries, the quantity of the production is measured. Also, the product or component functioning is also measured. Hence, the measurement is very important in industrial development. Second, adaptation of new technology. The measurement is significant in adaptation of new technology. If you want to adopt the new technology or implement the new technology, we need to do certain measurements in our workshops or some workspaces. For predicting people's likelihood of adapting the new technologies and product. Yeah, that is by estimating and costing. Third, environmental monitoring. Environmental monitoring system is a process that monitors the quantity or quality of the things in environment, like relative humidity, temperature, dew and frost point, pressure, flow, flux, and even the carbon dioxide level in the environment. Then engineering design. Measurement is fundamental to control, to improve, and to verification. We measure success and failure based on the judgment which arises from the measurement itself. So we will be able to decide whether the product is successful or whether it is a failed. And on what basis we decide this? We decide this based on the judgment or the data which we are getting from the measurement only. Okay. So next, fifth, scientific advances. In the field of research and development, the measurement is a vital component. That means very important, which provides a lot of information and data to take on the next work in that field. Next, health and safety. Measurements are very important in case of health and safety. That is, the performance of a heart is known by the measuring. That is, by counting the number of beats per minute. Yes or no? That generally we regard it as a BP. The RCB and RBC and WBCs are measured and expressed in counts. Yes or no? And many such examples. Generally, there are many requirements of measurements process. Importantly, we have standard used for the comparison must be accurately known and commonly accepted. Yes or no? So the standard which we use for the comparison should be commonly accepted and should be accurate. Yes or no? And the standard used for the comparison must be accurately known and commonly accepted. Then the procedure and the apparatus which we use during the measurement should also be commonly accepted and it should be provable. Okay, the step by step manner which we which we follow during the measurement should be provable or it should be reproducible. So these are the basic two requirements of measurements. So next, what are the factors to be considered in selection of measuring instruments? So there are several aspects to be considered, but let us see one by one what are the factors to be considered. So first factor is accuracy expected from the instrument. So if you have a high expectations of accuracy, then there are certain set of instruments to be considered. If the accuracy is not so desired, then there are certain instruments. Second, the time of taking final data required for the measurements. Yes, if the time of data which is required, if it is high or if it is low, on based on that also we can decide which instrument to go. Next, we have the cost of measuring instrument. If the cost of the measuring instrument is very high, then certainly that will definitely uh, affects the manufacturing process. Yes or no? So if you require very accurate or very high precision instruments, then the cost will be in depending on that. And if it is not so accurate, is not so required, then that will also affect the cost of the measuring instrument. If you require a very costly one, they are available. If you require affordable instruments, then they are also available. The type of data displayed, that is if you would require the data to be displayed on the monitor, or you want that data to be displayed along with the recording, then we can go for the integrating one, or you need the photographic. So depending upon that also you can choose the instruments. Then you have the measuring quantity to measured as a constant value or it is a time variant. Certain measuring quantities are constant value and some are depending upon the time also. So they change depending upon the time. So depending upon that also we need to decide whether which instrument we need to go. So these are the basic factors to be considered. So let us learn the methods of measurements. So what are the methods of measurements? First one, direct comparison method. So a comparison means we'll compare the primary or the secondary standard with the unknown quantity. The results are mainly in numbers along with the SI unit. Okay. And we are comparing here means we are comparing the standard, usually a secondary standard, with the unknown quantity. If I give an example, in the case of length measurement, the meter scale which we use or the tape for the longer measurements is regarded as the secondary standard. And one thing which we need to understand here is the direct comparison method involves the human sense, and usually that will vary from one person to the another person, and that makes the measurement highly undependable. In case of research and scientific work, the direct comparison is not at all suitable. Why it's not suitable? Because it's not accurate. For example, for the direct comparison, look at the picture. A person is measuring his height and he is comparing with the scale. The scale is called as a standard scale because it is predefined, and the height of the person is regarded as the unknown magnitude. And here the person compares his height with the scale and he'll get the value. The second picture explains a carpentry work here. A person stretching the tape along the wood slab, okay, and he'll compare the wood with that tape and he'll get the value. That is particular the length here, or he can get the width also, height also by using the tape. So next, second method is the indirect comparison. Okay, so we are doing the indirect comparison through the use of calibrated system. We make use of calibrated system in this case, that is the indirect comparison. So here in the calibrated system, we have a chain of devices that work together. We call it as a measuring system. Okay, now, so there are different devices. They will be working together, and they can be regarded as the measuring system. The sense which we want to measure, no, so that sense will be measured by this indirect comparison. Okay, and then the results which we are getting from the indirect comparison by the use of calibrated systems are more reliable and they are accurate. Okay, so these instruments will have the certain instrument for processing and converting the input into analogous quantity. We have control, that is remote control, telemetry, and then amplification and filtering units in these calibrated systems. So the picture shows the different examples of the calibrated systems. Now let us learn the terms applicable to measuring instruments. So before studying the different types of measuring instruments, we need to learn certain terms, certain definitions, which are vital to learn. Okay. So first one is precision. So what do you mean by precision? It's an ability to reproduce a certain reading with a given accuracy. Okay, so we call it as an ability of an instrument. So what kind of ability it has? It has an ability to reproduce a certain reading again and again. Okay, so we can also tell or call it as how close, okay, how close the measured values are with each other. Okay, so we have taken the first reading and the second reading and third reading, and all these three readings, how close they are, we can regard it as a precision. So we can tell it has a repeatability of a measuring process. So repeatability means ability of a process to repeat itself. Okay, repeat the value again and again. Precision is a very important characteristics that describes the validity of any measurement. Okay, the measurement's validity mainly depends upon the precision. We can also regard this precision as a degree of agreement. Okay, DOG. Okay, the degree of agreement between the repeated results. Let us consider an example. There are two set of measurements here. Okay, so we have taken trial 1, trial 2, and 3 and 4. So on different trials we got the different values here. Here it's displaying the weight measurement. So in the trial 1 we got the mass has 100 grams, in second 100.01, third 99.99, and fourth 99.99. In the second set of values, we have taken four trials, 1, 2, 3, 4, and the values are 100.10, 100.00, 100.88, sorry, it is 99.88, 100.02. So if you compare these two set of values, we can easily predict which is more precise. So the first set of values are more precise because the trial 1 values, trial 2 and 3, 4 values are very close to each other. They have high degree of agreement. Okay. So if you see the second set of values, they have very large closeness, or they are not very close to each other, or they do not have the high degree of agreement. Let us learn the second term related to measuring instrument, that is accuracy. What do you mean by accuracy? Accuracy means the closeness between the measured value and true values. Okay, measured values are the values which we get during the measurement, and the true values are the values which we know previously, or it can be said as a standard values also. So see here we have a picture representing the accurate and inaccurate. Okay, so a dead weight of 100 kg, okay, it is placed on a weighing machine, okay, a weighing instrument, and it's showing 100. So we can easily say here the dead weight has a 100 kg, and its indicated weight or measured weight is also 100 kg. So we can say it has a high accurate. Okay, if you see the second instrument here, 100 kg is there, but it's showing 98.89. So there is a deviation. Yes or no? So the values are not close to one another, and they do not have the high degree of agreement between the measured value and the true value. So we can be tagging it as a inaccurate measurement. So we can say the accuracy has the high degree of agreement between the measured value and true value. True values are nothing but the average of infinite numbers of measured values taken under the same condition. Okay. Under the same condition, if we are taking n number of measurements, okay, by an instrument, and condition is that that instrument should not be affected by any systematic error. Okay, we can say that instrument is idle instrument. Although the term is generally used in device specification, it is really the inaccuracy that is specified. So if you see, there are different instruments, they have specified with the accuracy, okay, but it's not the accuracy which they have indicated, but it is indirectly they are giving the inaccuracy, okay. Accuracy might be given for a component of measuring system or for a complete system. Okay. There is a system and that system is made up of different components. Yes or no? So the accuracy may be given for whole system or it may be given for an individual element of that system. Okay. For example, you have a sensor in that. So for that sensor, the accuracy may be given, or for the complete system, the accuracy may be defined. Let us understand the precision and accuracy. Okay. So the picture represents the precision accuracy, okay, comparing each other. The precision on the x-axis and the accuracy on the y-axis. So let us consider the first circle. Okay, here the circle represents the set of values. Okay, and the dotted red dotted line dots are there, no? So they are the values. Okay, so if you consider the first set of values, okay, so it is accurate but not precise. They are accurate but not precise. How? Why they are accurate? They are accurate because they are very near to the true value, but they are not precise because the values are not close to one another. The dotted, the dots which are there, they are not near to one another, but they are near to the true value. So we can say it as a accurate but not precise. Consider the second set of values. If you see here, these set of values are precise and accurate. Why? Why? Because all the points are near to the true point. Okay, that is, all the measured values are near to the true values. Okay, and they are near to one another. The closeness between the one value with the another value is high. Okay, and the agreement between the one value and the another value is high. So we regard it as a precise and accurate. So if you consider this third set of values, they are not accurate and not precise also. Why? If you observe the points, the dotted points, red dot, okay, so they are not near to the true point or true values, and they are not near to one another also. So the agreement between the true value and measured value is also not there, and between the values are also not there. So can we regard it as a not accurate and not precise? Yes. Consider the fourth set of values. If you observe here, they are precise. Why they are precise? The points, the different points, okay, the set of values, they are close to one another, but they are not close to the true value or the true point. The agreement between the true point and the different values are not there. Okay, so hence we regard it as a high precise but not accurate. So next term, okay, that is sensitivity. Sensitivity means it's an ability of an instrument to detect the small difference in the quantity being measured, that is input. So if there is a slight difference in the input, the instrument should be able to detect it. So that we call it as a sensitivity. And it is generally denoted by the symbol K. It is important characteristics of a measuring system. Yes, sensitivity is an important property or a characteristic of an measuring system. Sensitivity means the ratio of change in input to change in output. If you divide the change in input with the change in output, then you will get how sensitive the instrument is. Sensitivity is determined during the calibration. So when we'll come to know how sensitive the instrument is during the calibration process. If any errors in determining the actual sensitivity, if you are not able to find out the actual sensitivity, that will leads to the systematic error, that will contribute towards the systematic error. Okay, we call it as a systematic, or sorry, the sensitive error. We call it as a sensitivity error, which affects overall readings. Okay, in system of electrical output sensors, the sensitivity can be increased by using simple amplifiers. In case of sensors, if you want to increase the sensitivity, that is, for small change in the input, it should able to give the values, or it should be able to detect that small input also, that is small change in the input, then we can make use of the amplifiers. So these amplifiers in the electrical output signals will increase the sensitivity. Let us take an example. The figure shows the thermometer. Okay. So here thermometer, the sensitivity can be considered as the change in the height of the mercury column per degree of temperature change. Okay, for 1 degree of temperature change, okay, what is the change in the height of the mercury column? Okay, that can be said as the sensitivity of the thermometer here. So let us learn the next term, that is repeatability. So what do you mean by repeatability? The repeatability word is made up of two words, two root words. One is repeat, another one is ability. So can we say it as a ability of an instrument to reproduce the output, okay, again and again? Okay. So when the same input is applied to an instrument repeatedly under the same condition, okay, under the same condition, if we are applying the same input, okay, and if you are taking measurement again and again, the instrument should be able to give the repeated values. So for that we call it as a repeatability of the instrument. Inability to repeat a measured value exactly is known as the repeatability error. Yes, if the instrument is not able to give the repeated values, then we regard it as a error in the repeatability. It should be noted that the hysteresis is not a cause of repeatability error. Yes, hysteresis will not be affecting the repeatability error. Okay, the hysteresis is a separate error. We cannot include in this repeatability error. So next is range. What do you mean by range? Observe here, a speedometer has been displayed. It has a range from 0 to 120. Means the speed being detected from 0 to 120. The maximum value is 120 and the minimum value is 0. So the 0 to 120, we regard it as a range. That is, range is 0 kilometer per hour to 120 kilometer per hour. So the speed can fluctuate between the 0 to 120. A measuring system is only designed to operate over a specified, okay, range of measurement. Okay, so for a set of range, okay, only a certain specified range the instrument will be designed. Okay, so behind this range, okay, it cannot give the values. If it gives also, the values will not be correct. Values out the range are not expected to produce the useful output. Yes. For example, a voltmeter may have a range of 0 to 10 volts. Okay. So if the voltmeter is reading less than 0 or greater than 10, then the output will not be any useful type. Okay. So that is, it cannot give the correct response for the input of minus 5 or 13 volts. Minus 5 is less than 0 and 13 is greater than 10, which is out of the range. Next, threshold. What do you mean by threshold? Threshold means a minimum value of input which is required to cause a detectable change. Okay, if you want your input to be detected, that input should be of certain value. Okay, that certain value is minimum value. Okay, if the input increased generally from 0, okay, we are increasing the input from 0, there will be some minimum value below which no output change can be detected. Okay, if the instrument input increases gradually from 0, there will be some minimum value below which no output change can be detected. Okay, this minimum value defined as the or regarded as the threshold of that instrument. Okay, let us see. Here the graph shows the threshold. Okay, on the x-axis and the y-axis. On the x-axis we are taking the values, and the on the y-axis it is response. Okay, so for up to certain input there is no response. Okay, after certain value the response is increasing. Okay, there will be detect in the response. Okay, so that point, okay, the point from where the graph is increasing, the curve is emerging, so that point can be called it as a threshold value. Okay, minimum value for the output to be given. Okay, congratulations, you have successfully learned the following topics. What do you mean by the measurement? What are the requirements and significance of measurement? What are the factors to be considered in the selection of measuring instruments? And what are the methods of measurements? The list and explain the terms applicable to measuring instruments. So see you in the next class. Thank you.